Hello, happy Friday. It's Food Safety Fridays. My name's Simon Timperley from the International Food Safety and Quality Network. Today's topic is modified atmospheric packaging and testing for gaseous contaminants. And today's guest presenter is our good friend Maria Sandoval, Lab Director at Trace Analytics LLC. Good morning, Maria. How are you?
Good morning, Simon. I'm doing well. Okay. I'm on the other side of the pond from you, so I'm over here in Texas.
Austin, Texas. And
Austin, Texas.
Have you got your cowboy hat anywhere?
Well, you know, it's in the car next to my horse.
There you go. And what's the time there at the moment? Time check.
So right now it's 10 a.m. Central Time.
And the weather?
The weather is slightly cloudy with a breeze. It was 72 degrees Fahrenheit.
Very nice. And I'm over here in the UK, sunny Manchester. Cloudy, mixture of cloud and blue skies, bit breezy, a bit cool, but spring is in the air, everybody. Tell us where you're joining from in the sidebar. We always love to know. A few shout outs. Johnny Strickland from North Carolina, Sushma from Germany, N. Mishra from Chicago, Mulenga from Zambia. You're all welcome. Marcella from London, UK. You're all welcome. I'm going to play the sponsors ads now, of which Trace Analytics are one of the kind sponsors. We're back shortly for Maria's presentation. Okay, I'll be back for the Q&A later, but for now, I'll hand you over to Maria.
Awesome. Thank you so much, Simon. So like Simon mentioned, today we're going to be talking about testing for gas purity and contaminants in modified atmospheric packaging. A little bit about the company that I work for. We are Trace Analytics. We have been in compressed air and compressed gas testing since 1989. We are ISO 17025 accredited, which means we have a high standard for quality management systems and a high standard of accuracy and precision. We test to SQF, BRCA, ISO 85 specifications, ISO 14644, and all of the other specifications that some of your companies may require because of SQF or FDA or BRC requirements. We have a handful of members who contribute to regulatory and standards bodies like NFPA or ISO 8573. We have state-of-the-art equipment here, and we work with clients all over the world. So in the next coming slides, if you guys are interested or you have further questions, please, my email address, phone number is down at the bottom. You can reach me there at any time. So a little bit about me. My name's Maria Sandoval. I've been the lab director for Trace Analytics for about 5 years now. I have over 20 years of experience in microbiology and molecular biology. I am currently the project leader for ISO 8573-7, and that is specifically the microbiology contaminant testing for compressed air section. I sit on the ISBT Gases Technical Committee and the 3A Sanitary Standards Working Group 12 Committee, as well as others. So let's really get into it. This talk today is not going to be specifically about modified atmospheric packaging, how to make it. This is particularly about checking the purity and the contaminants that are potential inside of modified atmospheric packaging. So I think we can all agree that we're glad that we no longer have to store our food inside of clay pots the way they did way, way, way long ago in the BC era. You know, we've moved on from barrel storages that used to be in the medieval time. We've moved on from paper and extensive salt curing. And now we're into this era in the last, 20, 30 years of active packaging, which gained popularity because you were able to create better preservation, extend shelf life, reduce food waste. And it was based on a lot of this, like in this case, silica gel, right? It's actively pulling the moisture from the packaging material. And then you move on to more present day, and we have things that are like antimicrobial bags. We have odor absorbing pouches. And then we have things like modified atmospheric packaging. And so what is that? That's using gas blends to preserve the shelf life, the quality of the products that it comes in contact with. So here on the right, you can see a couple of generic examples of what modified atmospheric packaging can look like. You've got your meats, your fishes, your salads, your veggies, your fruits, things like that. And so the power of this packaging is that, one, yes, it is a packaging technique. So you need to be mindful of like SQF regulations when it comes to packaging requirements and regulatory quality requirements. And these packagings exist. They exist to extend the shelf life, to make sure that your product can remain fresh. And if it is a perishable product, that it can remain without spoilage or slow down the organisms that cause spoilage by changing the environment inside the packaging. And it does that by modifying levels of oxygen, carbon dioxide, and nitrogen inside of the packaging. Now, I know there are a few of you that are probably MAP. At this point, I'm going to call it MAP, modified atmospheric packaging. I'm sure there's a few of you on this call that are experts on MAP, and you know that you can also use argon, you can use other gases. But for simplicity purposes today, we'll talk more on O2, CO2, and N2. And also, these atmospheres also aid in inhibiting the natural ripening effect. So all to say, now we are able to do preservation of freshness for your end products. So that's the power of MAP. But a lot of us know that buying certified cylinders of nitrogen to use them every day if you are high production is not feasible. So more than 90% of facilities that are using compressed air or compressed gas are 90% of food facilities, are using compressed air or compressed gas generators on site. So what does that mean? If that many facilities are using compressed air or compressed gas, it makes it the fourth utility. It's up there with water. It's up there with electricity. It's because your site cannot function without it. And if that is the case, then you need to make sure that you are in control of this utility. So a lot of facilities that are food-based, beverage-based, are regulated by audits and regulated quality systems. So this, going forward, the slides will be geared towards customers that are in need of adhering to audit regulations. But I also want to say, if you are not required to audit, that's okay. But it is important to have integrity for your end product, and being able to control the environment that is directly in contact with your food is of the utmost importance for safety and product health. So when we're utilizing compressed air and gases for modified atmospheric packaging, this is kind of a generic cartoon of what it looks like, right? You have a nitrogen gas source somewhere up top. You have an oxygen gas source somewhere in the middle, and then you have CO2 gas source. And then they're plumbed into a gas blender at some point, right? And they are creating this modified atmosphere at the output of the gas blender to make the packaging box. And so if you just take a minute to even look at this cartoon, right? This is a generic cartoon. Everybody on this call knows there's likely feet, if not miles, of plumbing involved in getting your nitrogen, oxygen, CO2 to a gas blender. But if we just look at this cartoon, we can see there are many, many locations that are susceptible to leaks, susceptible to any kind of external contamination. And so what I'm looking at here are plumbing systems, right? The connections for your plumbing systems. Is the plumbing material acceptable for the type of gas? There are some gases that are corrosive. There are some gases that are inert. The input valve at the gas blender, these check valves that you see here, the output to the packaging, all of these are what I would consider high risk areas that need to be monitored or controlled. So what's the risk of having contamination in a modified atmospheric packaging? Well, obviously, if we talk about recalls, everybody cringes, but it's true. If you know that you're sending out a product, let's say fish, right? And you end up having to recall that, you lose brand integrity, you lose the product itself, all of that labor. So it's devastating to your bottom line and to your brand reputation. There's also loss of product. There's particles, water, oil, microorganisms, and gases. All of those can aid in impacting the quality of the gas or your gas mixture. And so these can lead to damaging the products and creating a shorter shelf life for your end product, right? And how is that even beneficial? That's not good for you. You need to be in control of those modified atmospheric gases and making sure that that is not a variable for the shelf life of your product. So what I'm showing here is just a small subset of what an example of a MAP gas could look like for fresh, whole, and prepared fruits and veg. So you see this is 90% nitrogen, 5% carbon dioxide, and 5% oxygen. So when I see this as a microbiologist, I'm thinking, awesome. This is very close to an anaerobic environment, very close to an environment that does not have oxygen, which means it will slow or inhibit the growth of microorganisms. If your oxygen is too high in this scenario, then the organisms are going to be happier and they are going to want to reproduce. They're going to want to divide. They're going to start spoiling your end product. And so this is where purity really comes into play. I know it's only 5%. How could the organism know? This is the entire evolution of microorganisms. They want to survive. And so they will take that extra 1%, 2%, 3% of oxygen and exploit it and spoil your end products. So in the next coming slides, we'll be talking about purity in that manner. And so there are common regulations and assessments that need to be done if you're using MAPs. And so a lot of that is FDA food code. HACCP critical point analysis and assessments, right? If I tell you this is direct contact to your product, that is high risk, no matter how you split it. And so our regulatory bodies, SQF, BRCGS, they all have recommendations if it's in direct contact. And we'll get to that in a little bit. But again, this purity analysis is different than contaminant analysis, which we'll talk about in a little bit. And the difference is because just adding a little bit more oxygen or a little less nitrogen can devastate the overall product that you have. And so what are these regulatory bodies talking about when they talk about being in control of your compressors, of your hoses, of your air quality? So compressors are required by SQF and BRCGS to provide requirements for compressed air systems to ensure air quality and prevent product contamination. That right there tells you that if you're not testing your air and you're not in control of the purity and contaminants, you're out of compliance. And so companies like Trace Analytics can help you. And we'll get over to Toolbox in a little bit about our risk assessments, about all the tools that we have in our shed to help you guys out. But these regulatory bodies are asking you, they're saying, look, we understand that this is a big deal, but this air that you're using is in direct contact. You need to be making sure that your compressor is clean, that it is maintained, that you are watching for repair requirements. You need to make sure that hose reels are not touching the floor, right? So it's not enough to be using your map and having your plumbing. It can't be loose and on the floor. Air quality testing is required based on risk-based monitoring. If it is in direct contact of your product, and modified atmospheric packaging gases are, it needs to be tested at minimum annually. So I want to stop for a second and kind of talk about that minimum annual testing requirement. I think all of us know that there are typically 4 seasons, unless you live in Austin, there's only 2. What that means is that organisms, environments change seasonally. So yes, right now, these standards are only asking you to test once a year, but you know that the environment changes at least 4 times a year. And so why not test your environment at least quarterly? That's making sure that during the rainy season, you have control over the environment. Compressors take in ambient air. Ambient air is a part of the environment. The environment is changing. Unless you have your compressor inside of a clean room, you are susceptible to change. So just keep that in mind while we talk. Again, we'll hit on it later in the later slides, but I just want you to be mindful about thinking about minimal testing and what it means to be in control. So when we're doing purity testing here at Trace Analytics, we utilize a source bottle, which you see here. It's a very simple test. You have an adapter. The input of your air goes in through the left side and exhausts up through the source bottle and is exchanging out the indicator gas, which tells the laboratory on our side that you've tested accurately. We can test for the purity of nitrogen, oxygen, and argon gases, as well as gaseous contaminants like CO2, methane, carbon monoxide, and total volatile hydrocarbons. And so if we take a second to think about specifications, yes, there are some regulatory bodies that require ISO 8573 testing, but a lot of the time there's no guidance on how to really approach purity testing specifications. Can you be off by 1%? Can you be off by 2%? So I encourage your quality team to do a risk assessment and then call us, and we can help you build a custom specification that is based on your quality system risk assessment. And that way you guys can have control throughout the year, at least 4 times if you're Maria, and really get a good trend analysis and use that trend analysis to show the power of your quality system. So when it comes into questioning purity, one of the major questions is, what are the sources of contamination? What am I looking at when I do see that my oxygen is off, or I do see that my nitrogen is off, or I do see that my total hydrocarbons is increased? What does it mean? Well, it's possible that you have off-gassing. So we know gaskets, we know seals, we know rubbers, and all kinds of materials off gas based on heat, based on age, based on wear. And those off gassings, depending on where it's coming from, can get into your ambient air, can get into your compressed gas, and show up that way. The other way, and likely the most common way, is a leak. You have a leak somewhere. Maybe you changed out plumbing. Maybe your connector is not accurate, but there is an introduction of ambient air into your system. And then lastly, the system isn't producing the appropriate quality after a certain period of time. And that's just simple wear. And that's where SQF and BRCGA and FDA all require that you are maintaining and repairing your compressor regularly. So when we move out of the purity discussion and we move more into the common contaminants, we talk about particles, water, oil, microorganisms, and gaseous contaminants. So gaseous contaminants are slightly different, well, very different than purity. Purity is talking about, I'm saying I need 9% nitrogen in my air stream. Gaseous contaminants is saying you have 2 ppm, a total volatile hydrocarbon, in your gas line. You shouldn't have it there. Where is it coming from? Let's do a troubleshooting. Particles, that's all dependent on your piping. That's dependent on your filtration. What water? Pressure dew point. So you want to make sure you have a correct pressure dew point. I've already talked about microorganisms. They want to live. Their sole existence is to reproduce and survive. And so if you introduce any amount of water above a certain pressure dew point that is conducive to that species or genus, you will run into microorganism issues that are dependent and on your water, on your pressure dew point. Microorganisms can also feed off of your oil aerosols. So a lot of these common contaminants play off of each other, right? If you have water, then you tend to have rust. And if you have rust, then you'll have particles. So all of this can be mitigated with regular testing. And I personally feel like once a year is not necessarily enough. What you see here at the bottom is a real life example of what a customer of ours who was food-based, who was testing for a class 2 particles and oil aerosol contamination purity class, and they failed. And you can see that they failed. This has visible particles in it greater than 5 micrometers, which is not allowed for class 2. And then you can see the discoloration are oil aerosols that have impacted the filter. So it is possible to happen, and it is possible to happen in your 1-year test. And so what happens during that annual test, if this pops up, it means all of these samples prior to your last annual test are in question. It's possible that this became bad, a week prior and you didn't do any map sealing that day, but it's also possible that you've been having this problem for 6 months. And because we're only doing annual testing, where is the integrity, right? So things like that. And that, again, I harp on it, is why risk assessments are so important. So looking at our typical purity classes that are requested by people from the FDA, the SQF, BRCGS users, we can see here, we can hop down at the bottom and see for direct contact, it's typically 221. And I showed you what a failure of 221 looks like, but typically that is what it is. And they suggest using ISO 8573. Again, ISO 8573 is the compressed air contaminants testing methodologies. And so when you see something that says 221, it's particles, water, oil, purity class 2, purity class 2, purity class 1. And so when I showed you those visible particles over here, right? These visible particles are greater than 5 micrometers. If we go over here, it says none detected for particles greater than 5 micrometers. So they fail automatically for this particle class. And then if the oil aerosol ended up being greater than 0.1 milligrams per cubic meter, they would fail for that as well. So again, it goes back to having control, and is 12 months in between testing enough control for you? I don't know. That's something that your risk assessment is going to have to determine. So if you do choose to use us, we have this really cool kit. It is able to simultaneously test your gaseous contaminants and purity. It can test pressure dew point, water vapor. It can test your oil vapor. It can test your oil aerosol, all in one kit. And so depending on the risk that you have for particles, if you need to be looking at particles that are 0.1 to 0.3 micrometers, then we have another option for particle testing, and that's a laser particle counter. It's all adhered. It all adheres to ISO 8573. They're calibrated. So that's another option for looking at particulates, microscopy or laser particle counters. You can also do by weight if you have a low risk. But at this point, if you're using MAP, it's high risk, and I would recommend class 1 or class 2. For pressure dew point, we also do water vapor tests. And then for total oil, we do charcoal tubes, oil aerosol, gaseous hydrocarbons. So oil vapor are hydrocarbons that are C6 and higher, so hexane and higher. And then for gaseous hydrocarbons, those are the lighter weight hydrocarbons, so pentane, things that are C5 and lighter. And let's go forward. And so one of my favorite tests as a microbiologist is the microbial testing. All right, we've already talked about how a lot of these analytes can influence the other analyte. So if you have water vapor in your line, then you typically will have rust. You could have rust, you could have particulates, but likely you'll have microorganisms, right? Because they need moisture, at least some of them need moisture to reproduce and to be viable, which goes into like the buzzword for a lot of you food folks. Is your kill step before or after? And so really think about that as well. Is your kill step before or after your MAP introduction? And if you're not testing for microbials after, high risk, in my opinion. So what does this do? You see here at the top left is the input to your gaseous line. You can just plug it in. Your nutrient auger plate is inserted right there where the arrowhead is. And it's an impaction sampler. So the gaseous stream will hit the TSA plate or whatever plate that your quality system deems. We can do anaerobic testing. We can do aerobic testing. We can do any number of things. We can do testing that is specific to organisms. So if you really only care about listeria, we can get chromogenic plates, things like that. And so all of these tests adhere to 8573 or 14644 or 14698 or 797. The list goes on and on. But overall, to say that it needs to get done. And what we do here at Trace is we do enumeration, which is a total plate count. That looks at bacteria, yeast, and mold. We do gram staining. That's just to do an overlying assessment of what the viable bacterial organisms are. So maybe you only care about gram negative. Maybe you only care, right, the coliforms. Maybe you only care about gram positive because you're concerned that your training technique is bad and people are putting their hands on everything. And maybe you really only care about E. coli 0157. And at that rate, we have a package for each care that you check. And the microbial identification is able to give you a genus and species based on a presumptive identification. So basically, I'm asking the organism 96 questions. I'm saying, hey, inside of my MAP airstream, is there E. coli? And if there is, what strain of E. coli is it? And our technology here at Trace Analytics is able to tell you that genus and species. So once you're finally concerned, all right, I've got purity. I understand purity. I understand the importance of making sure if I say I only have 3% of oxygen, that I really only have 3% of oxygen. And if I have more, it's likely because of these sources of contamination that are specialized to purity issues. But if I have particles, water, oil, microorganisms, or gaseous contaminants, the sources of those contaminations are a little bit different. And a lot of those times, the contamination sources come from your distribution piping. We talked about that a little bit. But it's important to remember a lot of facilities, especially in the Northeast, are in older buildings. And sometimes we think, oh, hey, I've got an oil-free compressor. It should be fine if I keep my distribution piping the same, even though that distribution piping has been a part of a non-oil-free compressor. You just contaminated all of your very expensive oil-free air because you didn't change out the piping. And that is because all the damage is done by the aerobic oil-free compressor years ago. There's also maintenance. If you are not maintaining your compressor, it's a huge problem. You guys know, I've seen so many videos of people emptying their condensate. I've seen videos of our technicians here on site, liquid oil coming out of their filter. It should just be oil aerosols coming to me. I don't do liquid oil here, and I'm getting liquid oil samples. I've got hoses and O-rings. You guys cannot be using rubber hoses. Rubber is a permeable material. Gases will exchange through that permeation. O-rings, you need to be changing them out. They degrade over time. They get worn. You tighten something, you loosen something. You tighten something, you loosen something. We talked about the environment. The environment is shrinking, it's heating, it's expanding, it's contracting. All of these things are making your compressor system a living organism, essentially, and we need to be in control. We need to be thinking about the ambient air because, and I mentioned it before, your ambient air is what's being intook into your compressor and compressed. Need to be thinking about leaks. Do leak checks during your preventative maintenance. Cleaning supplies. I can't even tell you the number of times we've popped positive for limonene or pinene inside oil vapor. Do you know what that is? Typically, not all the time, but typically, it's pine sol. It's a cleaning agent that has a beautiful piney smell. It's getting taken into your air compressor sample and getting blown out at the exhaust or getting blown out at the point of use. So just be mindful of your cleaning supplies as well. Synthetic oils, condensation, water buildup, corrosion, all of that. All of these are sources of contamination, and each of those sources of contamination exacerbate the other. So when it comes to deciding where you need to test, you need to be thinking about point of use testing. right off the bat, typically for this particular discussion, this slide is primarily for the modified atmospheric packaging point of use, where you are connecting your packages. If you want to be testing the source gas, the nitrogen, the oxygen, the CO2, upstream of the gas blend, then you should be thinking about testing before and after filtration. And then doing a comparison test is a wonderful way to get trend analysis information. So again, I keep harping on it. So you guys have control of your compressor system, because compressed air, compressed gas is dynamic. Why is it dynamic? Because it's dependent on the environment. Why is it dependent on the environment? Where are you getting the intake from? So all of those things matter. So I talked a little bit earlier about the toolkit and how Trace can kind of help you through this. We have this really awesome piece of collateral called a risk assessment checklist. You can go through it. You can write notes on it per your SOP. What is the description of your compressor, your make, your model? Is there an inlet filtration? You can ask things like, what kind of fitting, what kind of sealant do we use? Things like, is there point of use tubing? Is there point of use desiccant? All of these questions, one, help you to make a really good HACCP assessment. But additionally, if you test with us, we will ask you some of these questions. We'll ask you, hey, did you just change the filter out? And then you'll be able to say, actually, based on my risk assessment that was done prior to us sampling, this filtration system hasn't been changed out in 5 years or 2 years or whatever the system may be. We also have some material preferences at the bottom that help you get an idea of piping and fitting, sealants, valves, and from best to poor is located down there. So the other piece of collateral we have are monitoring plans. So we have the ability to help you guys plan these things out. We have an automated system that'll remind you guys, hey, it's time to test, because it gets hard. It's hard to remember when to do that. And so that is why when it is time for you to think about choosing a compressed air testing lab, I encourage you to think about the needs that your quality system needs. And so SQF, ISO, all of these require a quality system of the lab, and they all require that the lab that is looking at the samples have control. And the best kind of control is to have a third-party accredited ISO 17025 laboratory, and that's what we are, at least. We get our accreditation from A2LA. You want to ask of the compressed air testing lab, do they use NIST traceable standards? It's not enough to say, hey, you just have 90% nitrogen. I want to know that the lab who's doing this has a 5-point curve that says I tested this 90% against 100, 99, 99.8, 98, 90, 60, 75, and so on and so forth. Method validation, making sure that all of the possible variables have been exhausted and that your sampling and analysis methods are accurate and precise. So when it is time to make that choice, because a lot of you guys don't have an in-house laboratory, you will have to choose a third-party lab. I encourage you to look online for a lot of peer-reviewed data that compares traditional sampling methods like ours, source bottles, versus sampling gas sampling bags. A lot of peer-reviewed data has come out that has discussed outgassing. What does that mean? That means that the bags themselves are contaminating your sample. So be mindful of that. I told you that compressed gases, some of them are inherently corrosive. Some of them are not inert. And that could cause an interaction with the type of sampling bag that you're using, which results in outgassing, which means you're going to get A false positive. Leaks. These bags leak. They have a valve at the top. They are subject to going through the mail. They are subject to environmental stresses. It's hot, it's cold. They're being thrown around with your shipping. So they are at very high risk of leaks. Permeation. We know that gases exchange through certain materials, and a lot of these sampling gas bags are made of these permeable materials. They emit VOCs, and we just mentioned earlier, there's just a lot of restrictions and a lot of variables that are dependent on your shipping environment. So I do encourage you, when you are looking for a third-party lab, to please do yourselves a favor and make sure that the method that you're choosing is the best method that you can. It's a lot of money, it's a lot of time to invest in your facility, and it would be at a disservice for you to choose an inaccurate methodology. Now, moving on to the FAQ, some of the things that we've learned today is, when do you have to test? Well, at least annually, but I've harped enough. You guys have heard me enough beg you to test at least quarterly because of environmental stresses, because you guys probably get new people in annually, because of maintenance schedules, things like that. Which point of use do you need to test? The point of use needs to be monitored and determined of risk-based. And it makes me sad that I can't give you guys a straight answer. I can't say, oh yeah, Rex from Malawi, Africa, you need to test from this point of use 4 times a year, and you need to test for X, Y, and Z. Unfortunately, it's not that straightforward. You do have to do a risk assessment. And that's where I encourage you to come on over to our website, look at our collateral. We have the risk assessment documentation that'll help you determine whether or not you need to test that point of use. And in this case, if it's in direct contact and modified atmospheric packaging is, the answer is probably yes. Who cares about the quality of air? This is one of my biggest pet peeves. I don't think there's enough advertisement for air quality testing. We should all care. We know that these compressors are a fourth utility. We should all care, and it's all of our job to think about quality. So I encourage you to try to incorporate that mentality in your quality system when you're testing. Anybody can use our test kits. It's super easy to use. Taking a sample takes no time, and you just have to take the sample and you let my lab do the hard part and provide you with the results and some of the troubleshooting options for any unexpected results that you have. We also do out-of-spec investigations. We are 17025 accredited. We handle plenty of training on our end. We do calibrations of all of our equipment. We have NIST traceable standards. We can provide you with particles, water, oil, gases, environmental testing, microbiology testing. We have state-of-the-art equipment, and we service whatever country needs us. We are there for you. So I do want to stop yapping at you right now. If you have any questions, please, now is the time to ask me. We have about 20 minutes left, and I am here. Thank you so much.
Okay, thanks very much, Maria. Excellent. I'll just drop the slides. So if you can switch your webcam back on. Okay. Yes, questions. First one from Manoj. Is this composition of gases product specific?
So there is a lot of research online. If you are starting up a new quality system or you're starting a new facility and you need help to determine what type of modified atmospheric packaging you need for your product, there is tons of resources online. The example that I provided earlier was specifically for fresh food, whole foods. And that was 90% nitrogen, 5% CO2, 5% oxygen, which creates an anaerobic environment to slow down and inhibit the growth of microorganisms. That may not be necessary for the product that you care about. So I encourage you to look online and definitely stay in IFSQN. What are they? The blogs. There's a lot of helpful tips in there as well.
Okay, yeah. Question from Anna. Is there any specific method to assess quantity of N2/CO2 gases in the packaging? How nitrogen or CO2 atmo change in high altitude and air freight? Does that make sense?
Yeah. So what we're looking at, there are a couple tests that can be done for the actual gases that are already in your packaging. That is separate than what we're talking about here. What I'm talking about in my test is making sure that before it even gets to your package, you have control and assurance that your source gases and your blended gas are pure to the requirements that you need and are devoid of any contaminants. But if we want to go a little step further, yes, there are specific methods for nitrogen and CO2 purity testing. And the labs that I work with here can definitely talk to you about that if you reach out to us.
Okay, thank you. Question from Pradeep. Why do we need to add 5% O2 and CO2 rather than add 100% N2?
Yeah, that's a great question. So I was doing some research last night. It's actually because the 5% oxygen and the 5% CO2 create a happy environment for the enzymes that cause browning. They create a better barrier for the enzymes that cause spoilage in a way that an inert gas like N2 can't do on its own. So it does need help from oxygen and CO2 to make sure that you have crunchy food, to make sure that your vibrant red apple remains red. And that is done by the oxygen and CO2 and not solely by nitrogen.
Okay. And you're doing some research last night, was you, Maria?
Don't tell everybody.
Question from Nandish. Do we have any specification regarding the composition of MAP, so compressed gas for particular food products?
Yeah, and so that goes back to the first question that was asked. There are specifications for particular food products. You can definitely source all of the knowledge that is here at IFSQN, the blog area. You can start a conversation there. I am an expert on testing the purity and the contaminants of it, not necessarily the blend that is required for your particular product. But what I can say is once you do the research and you figure out the blend that you guys need, call me and I will tell you, yes, when you have finished setting up your system, it is pure, it is devoid of contaminants, and you're ready to go.
Okay, great. Nathan is asking, would you recommend Pseudomonas listeria testing? Pseudomonas?
Well, I wouldn't necessarily just recommend it off the blue, but if you have dairy products, yeah, you definitely should do listeria testing. Fun fact, Pseudomonas aeruginosa is the reason your dog's feet smell like Doritos. So, yeah, I would recommend it if you have done a risk assessment and you think that it's important for your end product. But if you're asking the question, it's probably because you're concerned. And if you're concerned, you should probably test.
Okay. Yeah. Question, another one from Nathan, actually. Additionally, aqueous mold with utilization of rose Bengal chloramethenical via filter testing. Hope it means something to you, Maria.
Yeah, so what we can do is we don't necessarily do aqueous molds, but we can do filamentous molds. We can even use rose bengal media. We can buy specialized media for any organism that you're worried about. So if you want to use something as selective as rose bengal, you can also use SDA, you can use PDA, you can use any kind of selective or nutrient auger for the organism that you're concerned about. We do have the ability to also just isolate the organism and do a phenotypic analysis and tell you what the genus and species is as well.
Okay. Shahida, what are the permissible limits for yeast and mold?
It's funny, every time I give these talks, that question is asked. And somewhere else, somebody's going to ask, what is the permissible limit for bacteria? And my answer is going to be the same. It is unfortunate, and I wish I could tell you, I am working with the ISO 8573 committee to get us limits. But right now, for compressed air specifically, there is no limit for bacteria, yeast, or mold. Now, that is not the same for environmental air, which there are limits, and we would have to go back and look at those specifications. But you can definitely use the methods for compressed air and the limits for environmental air. You can do that, and that's fine. Pharmaceutical customers use pharma specifications for compressed air coming out of their pharma products. So it's totally fine.
Okay, another question from Nathan. Additionally, do you recommend measuring headspace when performing shelf life studies?
I do, 100%. Now, again, this conversation that Nathan is asking is specifically about the map and product already in a package. My discussion today is talking about upstream of the already packaged product and ensuring that your MAP gas is pure and devoid of contamination. But yes, Nathan, to answer your question, you should do headspace testing.
Anand is asking, is checking of gas purity considered a CCP or OPRP in the food industry, or it depends on the HACCP determination, depends on the type of food product being packed?
Yeah, so I would consider it a CCP, but I would also say, because it's a CCP, you have to do an HACCP assessment. And that is going to determine the type of testing that you need to do. So a lot of acronyms for the same answer. The answer is yeah, you're going to have to do a risk assessment to determine the specificity of your test site.
Okay. Nathan again, I think. Sorry, the previous pseudo-listeria is meant in the presence of biofilms that have developed within the lines and likelihood of this cause adverse effects. That makes sense?
Yeah. So biofilms are very, very, very difficult to deal with if you already have them. I want to be mindful that there are two different ways biofilms can be discussed right now. They can be discussed as biofilms inside of the packaging on your product, right? That shiny layer that's on top of the deli meat inside of the package. Or it can be talked about in terms of the distribution piping that has a biofilm inside of the delivery distribution piping of your MAP system. Now, my talk is geared more to the distribution piping, but the answer is yeah, if you're creating biofilms in your food, there's already a problem, I think, and you should be testing for any type of microorganism.
Okay. Question from Dorcas. Can a food facility test their own compressed air, or it always has to be done by an accredited lab?
Well, and that's a really great question. Let's say that you're testing once a year, and you do find out that, in fact, your test has popped positive for particles, microorganisms, and you have now dipped below your purity requirement. When you come to get audited, the first thing the auditor is going to ask is, where's the verification of this data? How do you know that this data is real? And unless the lab that is inside of your facility is an accredited lab, you're not going to have too much assurance other than, yeah, we did the test methods and it popped positive. I think having your own testing lab is a wonderful opportunity to do monitoring, but I do highly recommend an accredited laboratory to do your quarterly or annual tests, because we are able to stand on our very, very large quality assurance and quality control system that we have in place here at Trace.
Okay. A question from Mohammed. After installation of a new compressor unit, what should be the testing frequency to validate it, specifically for microbial contaminants?
So one thing that I've seen before for validations are 3 days with 3 to 10 test samples from the point of use. And they do it 3 days in a row to make sure you have repeatability, reliability. That is what I've seen in the past for some companies. And for microbial contamination, if you're validating the system, it should be 0. If you have more than 0, you need to make sure that you have controls to make sure that it is not an external contaminant. New compressors shouldn't have any of that.
Okay, another question from Manoj. As a layman, how can we ensure the compressed air is free of water and mineral oil?
Yeah, so the sample testing methods that we have here at Trace are very user-friendly. If you want to just know about water vapor, we have a simple colorimetric tube. So you plug it into your compressor line, and then the compressed airstream will come up and it will change colors based on the water vapor that is present on the matrix. And it will tell you in real time, hey, you have this much water vapor in your compressed airstream based on the air volume that you sampled. With that being said, because it's in real time, you're able to troubleshoot, and you can change the filters if you find that there's too much water. Test again with another detector tube and move forward that way. For mineral oil, that's a little bit different, and that would involve whether or not the mineral oil is aerosolized liquid or if it's vapor, in which case we can handle that so long as it's not in liquid form.
Question from Pradeep. For oil and vapor contamination of compressed air, what kind of filtration systems can you recommend, like filter size, type, etc.?
So that's a really good question. That is going to depend on an HACCP assessment. And that is because particles that are 0.1 to 0.3 are typically for class 1. But we have seen in the past some people with ready-to-eat meals or whatever the case may be for their application require class 0. It's not common, but it has happened before. And so their filtration is required to be extremely more strict than a class 1 or a class 2. But for the most part, we see 0.3 micrometer and lower filtration for particulates, and pressure dew points being a little bit drier to make sure that you have inhibition of the microorganisms.
Okay. And question from Vishal. Can you give information about chlorination treatment to flour, and can we use MAP for bakery premixes, and if effective to do that, as mostly we face issues of weevils in pack during improper storage conditions in market or bakeries? A bit off topic.
Yeah, it's a little bit off topic. But what I can say about chlorination treatments for flour, you just want to be mindful about permeation to your actual product of flour. So just be careful, do a risk assessment.
Okay. I think that's all of them. Brad Kumar said, would you be able to do a webinar on CO2 fumigation? That's not your area, is it?
No.
No, I think that's it. Brilliant.
Awesome.
Thanks very much for your time today, Maria, and lots of great info and answering specific questions as well. So appreciate it. Thank you.
Awesome. Thank you so much, guys. Bye-bye.
Okay. Have a nice weekend.
You too. Bye-bye.
I'm just loading the certificate in the sidebar. We'll be following up with the recording, the slides, and the certificate to your registered email within the next hour or so. Thanks for taking part today. We'll see you on the next one, which will be in a couple of weeks. So just watch your inbox for the next invitation. Okay. Have a great day. Enjoy your weekend and see you next time. Bye.